Hey everyone, sorry, I guess I was muted. Can everyone hear me now? Welcome to my follow-up webinar. My first one, we went over how to generate an RTC token using Node.js and Express. Today we're going to use Golang and the Gin framework to generate both RTC and RTM tokens. Feel free to ask questions and follow along. I'm doing well. How are you guys doing? How many people are going to code along? Let's see. We have so we'll give a couple minutes for a few more people to join. Like I said, feel free to ask any questions in the chat. Maybe it's on that side for you. Below the video, I'll have some descriptions for things that will run in the terminal, such as some of the bash commands. I'll have the URLs for the dependencies, so you can copy paste them in as you code along. By show of hands, how many Golang developers do we have today? Even if you're an aspiring Golang developer, we'll lump you into the group. Looks like we have still a few people joining. And this will be recorded, so if for whatever reason you kind of get lost along the way and want to take your time and just follow along, I'll definitely be recording this, and we'll share that with all the attendees. Yeah, Zan, it definitely counts. So now, we're about 3 minutes in. I'll give it to the 5-minute mark, and then we'll start the first video. So to queue up the first video, please make sure you have an Agora developer account. You're already signed up, and you have your API or app ID ready to go. In the first video, we will do a very basic project setup where we'll instantiate our project Go modules so that we can use Go modules as the dependency management. We'll fetch our dependencies to make sure we have them installed, and then we'll open up the code, set up a very basic Go project with using the Gin framework. I like to use Gin over just the vanilla Golang framework because it makes it very clear as to your intention. You don't have to write a bunch of middleware code. Gin handles a lot of that. You can affect the middleware, no problem. Gin exposes a lot of that. We won't go into real detail for that. But I think without any further ado, we'll start queuing up the video. So for anyone that is new to this, when I play the videos, they'll take a few seconds to start up, and then they'll go right into it. Afterwards, I'll give a few seconds of time for it to catch up for everyone, depending on where you're located and how the CDNs cache. It'll make a difference as to the timing and everything. So there will be a little bit of lag before and after between me going live and the video. For that, I'll also take a pause here, and we'll get ready to start our first video. See you guys in a little bit. We'll start by creating a new folder. We'll call it Agora Token Server. We'll open that folder in terminal. Now we're going to want to set up our dependency management. So we'll use go mod init Agora Token Server to set up our Go modules. Next, we'll load the Gin module. So we'll say go get github.com/gin-gonic/gin. That'll download the Gin framework for our web service. We use the Agora token builder framework for building the Agora token. So So say go get github.com/agoraio-community/go token builder. Now that our dependencies are downloaded, let's open up the project in our text editor. We'll create a new file called main.go. We'll declare the package as main, and then we'll set up the main function. Next, we'll import the gin dependency. So we'll do import github.com/gin-gonic/gin. We'll start by defining our gin service. I like to call mine API. We'll say gin.default. Next, we'll set up a simple endpoint just for testing. We'll say api.get. We'll call it ping. And for now, we'll just use a generic function here. We'll pass in a reference to the gin context. And then we'll use that context to respond. So we'll say c.json. We'll give it a 200 response code. We'll say gin.h. We'll say the message. Say pong. Ping pong. Simple enough for our testing purposes right now, just to get us set up. Next, we'll want to listen on a specific port, so we'll say api.run, and I like to use port 8080. Now we have a very basic gin server set up, so we can test it out. Let's go to the terminal, open up, we'll say go run main.go. We can see our web service is running and listening on port 8080. So open up our browser. localhost/8080/ping. And there we can see our response pong. Now we can close our browser. We can interrupt the service. And we're back. Sorry, the volume might have been a little bit low. Working on fixing that for the next one. Was everyone able to code along and understand how we got the basic setup of the project? Cool. Hopefully, these next couple parts will be a little bit more in depth. So I'll cut myself a little bit shorter to make sure that everyone has time to sync up from the start of it. This next section, we're going to set up the actual token service for Agora. So setting up the endpoints and the functions that they'll call. And we're going to kind of just outline those functions first to get the overall structure of what we're doing. From there, the video after that will go through and do the RTC token, followed by video for RTM, and so on and so forth. Before we get into this next part, I'd like to throw out a poll there for you. So what's everyone's preferred Golang framework? In this project, we use Go, but there's things like Echo, Chi, Mux, and for the purists out there, always the option to go no framework. So with that said, I'm going to queue up the next video, and happy coding. See you soon. And go back to the code. Now we're ready to set up our Agora service. So let's create the endpoints. Say api.get. We'll start with the RTC endpoint. So we'll say RTC/, and we want a channel name. So we'll pass in channel name. We'll want the role of the user. So we'll pass in role, and pass in token type, and lastly, we'll pass in the UID. To handle this, we'll need a function called get RTC token. We'll do the same for RTM. We'll say api.get /RTM. We only care about the UID in this case. And we'll pass that to a function called get RTM token. We'll also want to get both tokens, so we'll say api.get. We'll call this RTE / channel name / role token type and UID. We're taking the same parameters as the RTC token, but this time we're going to call a function called get both tokens. So let's define our functions. We'll start with get RTC token. We'll pass in a reference to the gen context. We'll leave it blank for now. Do the same for get RTM token. And lastly, do it again for get both tokens. Since we're passing in a number of parameters, we'll have two functions to parse those out. First, we'll start with the RTC parameters. So we'll say func parse RTC params. And here we'll pass in a reference to the gen context. And then we'll want to return the channel name, the token type, and the UID as a string. So we'll turn those as string types. We'll also want to return the role as an RTC token builder dot role type, and we'll also return back the expiration timestamp. This will be a uint32, and lastly we'll return an error. Do the same for the RTM params, so we'll do parse RTM params, pass in the gen context. We'll return the UID as a string, the expiration timestamp again as an unsigned 32-bit integer, and an error, just in case. Since we have two different token types for our RTC token, we'll use a function called generate RTC token, pass in the channel name, the UID as a string, the token type. These will all be string types. Also pass in the role that we got from our RTC params and the expiration timestamp. From here, we'll want to return a RTC token. That'll be a string and an error, just in case. Sorry, again, I mute myself when I'm backstage. So welcome back. Hopefully everyone was able to code along and set up their token service and the basic outline structure. Now in this next section, we're going to be setting up the RTC token. So first we're going to fill out the get RTC token function, then the get parse RTC parameters function, and lastly the generate RTC token. And we break it up like this because later on when we go to generate the both RTC and RTM tokens, we'll want to have a little bit of abstraction so we're not repeating a lot of code. The super long functions, for sure. We're going to show them again later on, so feel free to code along, and I can even provide them, I guess, in this next function, this next section as part of the description, if that helps. Here, let me open up real quick the project and paste those function names in. So the first set of functions, or each of the functions, take all the parameters that we're going to be putting in and out. Let me share these real quick. For the generate RTC token, I think that's probably one of the longer ones. The parse RTC params and the generate token. Let me find the window again. We'll edit the description in this next section to have those as well. So you can copy paste them in case you miss them. And then the last one would be this one. So these are the really long ones. We'll paste them in. There we go. So in this next video, I've included the parse RTC params functional definition for all the return types, channel name, token type, all that. And then also for the generate RTC token. Those should be the two long ones. If I missed any, please feel free to let me know in the chat and I'll drop them in there. I'll queue up the video now and feel free to keep asking the questions. We'll stop after this section. See you soon. So here we'll go back to our get RTC token. Let's plan this out. We'll get the param values, we'll generate the token, and then we'll return the token. So from the parameter values, we're going to want the channel name. We're going to get back the token type, the user ID as a string, the role, the expiration timestamp, and the error. We get this all back from the parse RTC params. We'll pass in the context. Next, we'll want to check the error. So say if error is not equal nil, we'll let the context know we've thrown an error, pass it in. We will also abort with status JSON, give it 400 code, and then for the body we'll say message, error generating RTC token. We'll attach our error. We'll also give it a status code of 400. And then we'll return early if we run into an error. Now we're ready to generate the token. So say RTC token and token error will be what we'll get back from generate RTC token. Here we'll pass in the channel name, UID is a string, token type, the role, and the expiration timestamp. Now we're ready to return our response, so let's first check if the token error is nil. If it's not nil, we'll error. Also want to let the context know we've thrown an error. Pass that in there. And then we'll abort with status JSON. Pass in a 400 status. And the body will be status 400. Message will be error. Say error generating RTC token. And we'll show the token error. Otherwise, we'll affect the JSON context. We'll give it a 200 response code. And the body will be RTC token. So get back the RTC token that we generated. Cool. Now that we have the RTC token, let's move on to parsing those RTC params. So here, let's get the param values. Start with the channel name. This will come from c.param channel name. Next we'll get the role as a string. This comes from the param role. Get the token type. Next we'll get the user ID as a string. Lastly, we'll allow for the expire time. We'll set a default value for it. So if we pass the expiry value, otherwise we'll put a default value of 3600 seconds. So if the role string is equal to publisher, we're going to set the role equal to RTC token builder dot publisher. Otherwise, we'll make them a subscriber. So we'll say role equals RTC token builder dot role subscriber. Now, our expiration time came to us as a string. We'll need to convert that first to a 64-bit integer. So we'll parse that using string convert. Parse the expire time, base 10, 64-bit, and if there's an error, let's just bubble that up to the top. Say error, we'll format it. Failed to parse expire time. And causing this error. Now we'll pass in the expire time and the possible error, just to give ourselves an idea if anything goes wrong, where it went wrong along the way. Otherwise, we'll say the expired time in seconds is equal to unsigned 32 conversion from expire 64. Then we'll get the current timestamp, and we'll want that also as a 32-bit unsigned integer. So say time.now etc.unix, and we'll use this to generate our expiration timestamp. So our expiration timestamp will be a combination of our current timestamp plus our expired time in seconds. So now we're ready to return all our parameters. Return the channel name, the token type, the user ID is a string, the role, the expire time, and the error. Now last, let's generate our RTC token. So check the token type first. So if we're using token type of user account, that means we're using string IDs for the tokens, so we don't need to do anything to the UID string. So we'd say RTC token, and the error is equal to RTC token builder, build token with user ID, user account, sorry. And here we'll pass in our app ID, which we need to define. So we'll pass in the app ID, the app certificate, the channel name, the UID is a string, the role, and the expired timestamp. So we need to define our app ID and our app certificate. I like to use environment variables. So first let's make these global because we'll need them to generate all the tokens. Let's say app ID and app certificate. They're going to be of type string. Then in our main function, we're going to want to get those environment variables first. So we're going to say app ID env and app ID exists are the return values from when we do the OS lookup environment variable. So we'll get back the value and a boolean if it exists or not. We'll do the same for the app certificate. And again, we'll use OS lookup and pass in the environment variable names. Next, we'll check if the app ID exists or the app certificate exists, or if they don't. If they don't exist, we'll want to throw a fatal error because our token server just won't work without these values. So here we'll log out our fatal error. And let the user know that the environment's not configured correctly. Otherwise, we'll set our global app ID and app certificate each equal to the environment variable values that we got back. Okay. Now that we have our app ID and app certificate defined, here we get back our RTC token, so we'll want to return the RTC token and the error. Otherwise, if we're using the token type of UID, we're going to be using integer-based IDs, so we'll need to convert our string ID. So we'll start with a UID 64 and parsing error, and we'll convert from, so we'll use string convert parse to convert the UID from a string to a 64-bit. And then there's a parsing error. Let's let that bubble up. So we'll say error equals format error. were. And then let's return an empty string and our error. As long as our UID was successfully parsed, we'll then say UID we need as a 32-bit unsigned integer. So I'll do the little conversion from UID 64 to 32. Then we can say our RTC token and the error are equal to RTC token builder dot build token with UID, and here again we'll pass in our app ID, our app certificate, the channel name, our 32-bit UID, the role, and the expired timestamp. Then we'll return back our RTC token, and just in case any error we might have incurred. Lastly, let's do a catch-all. So if it's not a UID or user account, we'll just pass back an error. Let the user know that we couldn't figure out what the token type they passed in was. Show them the token type. And lastly, we'll return, well, first we want to log this error. And then we'll want to return an empty string and return the error as well. Hey everyone, and we're back. So I'd like anyone that has any questions up until now, please add them to the chat. Just to review everything we did in that last video, we filled out the generate RTC token function. We filled out the parse RTC parameters, and we filled out the generate RTC token function. Zahn, you're correct. In the next video, there's a missing comma in there, and we go and correct that, either an RTC token or RTM token or the both tokens. So if you see an error, please feel free to let me know what line you think that is, because as after this is done coding, I do. Good catch. So in the description, I say to pass the token error, but I write regular error. Yes, good catch. There is a place where we should be passing back the token error. Good catch, Zahn. It's not a breaking error, but it'll definitely confuse you if you run into an issue as to why that error is not nil. Are there any other questions, or did that part kind of make sense to everyone so far? Well, doesn't seem like there's any other questions. In this next section, we'll be building the RTM token. We'll be following a similar structure of filling out the get RTM token function and then the parse RTM params function. Here we don't have the generate RTM token function because we only have one token type or UID type, so there's no reason to add that layer of abstraction. We can just call the RTM token builder directly. And with that, we'll queue up the next video. So now we're able to generate our RTC token. Let's move on to generating our RTM token. So here we'll want to get the parameter values, build the RTM token, and then return it. Very similar to what we did for the RTC token. So we'll start by getting the UID as a string and the expiration timestamp, along with any possible error we could have encountered when we parse the RTM params. Here we'll pass in the context. Real quick, we'll just check if there was any errors. So if the error wasn't equal to nil, we'll let the context know we've encountered an error. Also abort with status JSON. Give it a 400 error code. And for the body, we'll show the status, say 400. And then we'll pass back a message. We'll say error generating RTM token. And return back. So next we'll build the RTM token. So we'll say RTM token error. We'll use the RTM token builder class directly here. We'll build token, passing in our app ID, app certificate, the UID as a string, the RTM role here. There's only one role, so user, and then the expiration time. Let's double check that we didn't get any errors. So if token error is not equal to nil, we'll log that out. Pretty important. And we'll also let the context know we threw an error. And let's create an error message. Let's say error generating RTM token. And here let's show that error. Say abort with status JSON, with 400 status, and then for the body, the status code is 400, and the error, we'll send back our error message that we just created. Otherwise, let's return back our RTM token. So we'll say context.json, give it a 200 status code, and then for the body, we'll say RTM token, and return our RTM token value. Okay, now before we can get both tokens, we need to fill in our parse RTM params. So here we're going to want to get the parameter values from the context again, similar to how we did it for the RTC. So we're going to say UID string is equal to c.param, and just get the UID param. From there, the timestamp again will be an optional query param, so we can say c.default query, and if we pass in an expire time and our expiry time, it'll use that. Otherwise we'll default to 3600. Again, we're going to want to do our conversion from the expire time to timestamp. So first we're going to convert from the string to the 64-bit. If we have any errors with the parsing, let's return that as well. If our conversion went okay, we'll get our expiration time in seconds, converting from a 64-bit to a 32-bit unsigned. We'll also get the current timestamp. We'll create our expiration timestamp using the current timestamp plus the expired time in seconds. Now we're ready to return the user ID string, the expired timestamp, and any error we may have incurred. Hopefully the RTM token part made sense, followed a similar instruction to the RTC token, where we parsed out the params and generated the token. So in the token generation, the only difference we did was we used the RTM token builder directly. A lot of what we did in RTC token and RTM token sets us up very well for this both tokens endpoint, because we'll be following a similar structure to RTC and RTM, kind of merging that all into a single functional call so that we can get it to the endpoint. Question, why are we converting the UID to a 64-bit and then a 32-bit one? The string conversion for parsing to uint always returns a 64-bit, so there's no way to go directly to the 32. I guess I could cast it right there. It just becomes a little less obvious what I'm doing. So I wanted to just be very clear that that casting and change needed to happen. Does that make sense? Give another minute or so if anyone has any other questions. No, the 64 param doesn't. It always returns a 64-bit. So you do have to cast it. I was looking into that too because I wanted to just confirm that it didn't return a 32-bit in some way, but you do always have to do the casting for that. Cool. So we'll start this next video. And here we'll generate both tokens following similar logic. See you in a little bit. So now we have our RTC params done, RTM params done. We're ready to generate both tokens. So this one's going to be a lot easier with all the other work we've kind of laid out for us. Oh, looks like I forgot a comma here. Let's fix that real quick. Now we'll get both tokens. We're going to want to get the parameter values. Then we're going to use those values to generate our RTC token. then generate our RTM token, and then return both of those tokens. So the parameters we want are the channel name, the token type, the user ID as a string, the role, the expired timestamp, and any error we get. We'll use the parse RTC params because that'll give us all the parameters we need. Next, let's check the error. So if RTC param error not equal to nil, so let the context know we've run into an error. And then we'll also abort with status JSON, give it a 400 code. And then for the body, we'll say status 400. And the message, so error generating RTE token. And we'll return the parse error. Okay. If everything goes well with getting our parameters, we're ready to generate our RTC token. So we'll say RTC token and RTC token error is equal to generate RTC token. We'll pass in our channel name, our UID string, the token type, the role, and the expiration time. Next, we'll generate our RTM token. We'll say RTM token and RTM token error. Here again, we'll call the RTM token builder directly. Say build token, passing in our app ID, app certificate, user account, which is our user ID as a string. The role is going to be RTM user. So we say RTM token builder dot role RTM, and then expire time. Okay, now before we can return, let's double check and see if we got any errors generating the RTC token. So we'll say if RTC token error is not equal to nil, we'll let the context know that we've run into an error. So we'll say c.error. We'll pass in the RTC token error. We also want to generate an error message. So we'll say error message is equal to error generating RTC token. And let's show that error. Okay, so now we'll need to do a abort with status JSON, pass in the 400 error code, and then for the body, we'll give it a status of 400, and we'll give it the message. We'll pass back our custom error message. Otherwise, if the RTM token is thrown in error, let's also do the same. Let the context know we've run into an error with our RTM token. We'll generate our custom error message saying error generating RTM token. Show that error. And then let's
So abort with status JSON. Again, for the body, we'll give it a status of 400. And for the message, we'll return back our error message. All right, so if we don't have any errors, we've generated our tokens. Let's return both of them. So we'll say c.json, we'll give it a 200 return code, and then for the body, we'll return our RTC token and our RTM token.
Hey everyone. Now that we have all three endpoints set up, hopefully the both tokens endpoint made sense, very similar to what we did before. Good catch, Zahn. There are a couple instances where I passed back the wrong error. Apologies for that. I'll make sure to correct them in the GitHub repo that I can share at the end of this. So all we have left now is to test our server. So if you're following along, you should be able to use go run main.go, which I think I have in the description. Yep, I have it in the description for the next video, along with links for all the endpoints. So when you get there, you can start your web service and then just click the links that I've set up. So you don't even have to sit there and type it all out. It goes a little bit faster. The section will be relatively short, just a couple minutes. Again, feel free to ask your questions, and then afterwards, I'll be here to answer your questions. So without further ado, let's queue up the last video and do some testing.
Now we're ready to test our token server. So let's go back to the terminal window. We'll run our main Go file. We can see we're listening on port 8080 and we have all our endpoints there. So let's start with localhost 8080. We'll start with RTC. So RTC/testing for the channel name. We're going to use publisher as our role, say user account, and 12345 as our user ID. We can see we get an RTC token. We can see it both in the logs and in the response. Next, let's do an RTM token. We'll do /RTM/123456. And we can see we get the RTM token as a string. Let's test our dual token endpoint, RTE/testing/subscriber. This time we'll use UIDs, 1234556. We can see we get both tokens. So everything seems to be working well. Let's give it one more test with user account. See, we get both tokens with a user account. And let's purposely give it the wrong token type. And now we see, okay, our error is also generating. So we know our server is working correctly, and we can generate our RTC and RTM tokens for our Agora applications. Here we can see all the different responses, the success for the 200s, and then the 400 and the error that we threw.
Hope everyone was able to test along and it worked. Please let me know if you ran into any issues with your server by leaving a comment in the chat. If you'd like to read the full tutorial, I've shared the blog post, and at the bottom of the blog post there is a link to the GitHub repo with all the code. The GitHub repo also includes a Docker container. Zahn, definitely reach out to me and we'll figure out what you did wrong. Probably a setup. But as I was saying, the GitHub repo has a Docker container as well. So you could run the Docker container and see this all working. Just input your app ID and app certificate in there. We have a few more minutes before we kind of get to time. So please, if you have any questions, please feel free to ask. Saw a lot of new faces or names, I guess, in the chat. It's interesting to see that most people are using both RTC and RTM tokens. It's really cool. RTM is great for administration and orchestration type things, whether it be screen sharing or muting video or other things of remote users, that sort of thing. For sure, definitely something if you haven't looked into, definitely a recommendation to take a look at Agora's real-time messaging SDKs. Thank you, William. Again, please feel free to reach out and ask if you have any questions, comments, or concerns. We'll also share a bit.ly link in here if we can. Thank you for joining, Dennis. If you're not part of our Agora Slack, please check out the Agora Dev Team Slack. Thank you, everyone. Thank you so much for joining. Ikanch, if you check out the blog down at the bottom, scroll all the way to the bottom and there's a repo there for GitHub. Again, thank you everyone for joining. Doesn't seem like there's too many questions. Again, feel free to reach out on Slack or email us, devrel@agora.io. We're always here to help. And best of luck on your RTE adventures. Till next time, everyone.